U.S. military news. The SM-6 is unique in several respects. The weapon uses what is called an active seeker, meaning it can send a signal or electromagnetic ping forward in addition to receiving them. This enables the weapon to better hit moving targets and fire in rapid succession. The Navy is preparing an emerging standard Missile 6 missile variant for combat by test firing the weapon engineered with upgraded software, enabling it to perform a range of functions to inlcude air warfare, ballistic missile terminal defense and anti-surface warfare capabilities, service officials said. The Navy successfully executed 4 flight tests of the surface-to-air standard Missile 6 Block I, SM-6 BLKI, off the Hawaiian coast between April 6th and 13th. The test marked a key step along the way to delivering a combat-ready weapon to Navy ships. I'm very proud of my team for the seamless planning and execution of these flight tests, which are the culmination of disciplined systems engineering efforts. These latest flight test successes demonstrate once again the versatile capability of SM-6 BLKI, Captain Michael Atner, Major Program Manager for Surface Ship Weapons, Program Executive Office for Integrated Warfare Systems, said in a written statement from Naval Sea Systems Command. These tests come shortly after recent Missile Defense Agency and Navy testing which simultaneously fired 2 standard Missile 6 weapons in rapid succession at a single ballistic missile target to assess performance against medium-range ballistic missile threats in the final stage of flight. Using an active seeker technology, 2 SM-6 missiles were able to simultaneously track and destroy a single target, greatly improving the probability of a target kill. You now have absolute assurance of hit no matter what the threat is doing. If the threat takes a turn and does some strange maneuver and the first missile is unable to sense it and engage it, the second missile will, Mike Campisi, SM-6 Senior Director, Raytheon, told Scout Warrior in an interview. A statement from the Missile Defense Agency described how a Navy destroyer fired a salvo of 2 SM-6 dual-eye missiles against a complex medium-range ballistic missile target, demonstrating the sea-based terminal endo-atmospheric defensive capability. The SM-6 is unique in several respects. The weapon uses what is called an active seeker, meaning it can send a signal or electromagnetic ping forward in addition to receiving them. Electromagnetic signals, which travel at the speed of light, send a signal forward before analyzing the return signal to determine the shape, size, speed or configuration of an approaching threat. Since the speed of light is known, and the time of travel is able to be determined, a computer algorithm is able to calculate the exact distance of an object. This technology is built into the SM-6, using software upgrades. An active seeker gives the missile to better attack maneuvering or moving targets at sea, because it is not wholly dependent upon a ship-based illuminator to bounce a signal off a target for a merely passive seeker to receive. This is the technology which allows a ship commander to fire several SM-6 missiles in more rapid succession or closer to one another in the event that a target needs to be attacked with more than one missile. A ship can illuminate or communicate with a missile, and at the same time the missile is looking at the target as well. On a pure active mode it can go on its own, Campisi explained. Now, SM-6 active seeker technology allows the missile to use its own built-in seeker technology to navigate without needing a ship-based illuminator. We had 2 missiles in the air and we wanted to make sure that we were in fact pulling in on the target and looking at target versus looking at the other missile that's in the air. Simulations all said the missile would never look at the other missile in the air however, but it's nice to prove that. Compared with the SM-3, the ship-fired SM-6 interceptor is designed to track and destroy lower-altitude threats such as a ballistic missile in the terminal phase of descent to its target. The weapon has been established with an ability to knock out ballistic missiles approaching from the sky. More recently, the weapon has been developed for a number of new offensive missions including surface attacks against enemy ships or defensive intercepts against anti-ship missiles closer to the surface. The SM-6 has also been capable of anti-air defense, equipped with an ability to attack or destroy enemy helicopters, drones and other approaching threats. The weapon has now been established as defensive, offensive and capable of 3 distinct missions. They are surface warfare, anti-air warfare and ballistic missile defense. You now have a multi-mission capability with 1 missile. That means that this missile could be moved at any ship at any time and have the exact same capability all three mission sets. That isn't set by hardware or anything else. Campisi and Navy leaders emphasize that the fast-changing threat environment means new offensive and defensive technologies need to emerge in order for the U.S. to maintain its edge over potential near-peer rivals. Along these lines, Russian and Chinese missile modernization is by no means lost on U.S. weapons developers. Ballistic missiles have been proven to be launched from any and all platforms, including mobile launches. We see it on the news. When the Russians parade their gear, you see their mobile launchers. You can see that the Chinese have mobile launchers. They can be launched from virtually any platform, Campisi said. SM-6 for surface attack. This most recent development comes on the heels of a successful test last year wherein SM-6 destroyed and sank a surface ship target off the coast of Hawaii, providing additional strategic relevance for a new offensive use of a missile previously oriented toward air and ballistic missile defense, Raytheon and Navy officials said. The anti-surface warfare test proved that SM-6 could attack a surface ship. It destroyed a Perry-class fast frigate. The big deal for us is that the SM-6 proved its capability with sea targets, Campisi said. The test, which took place at Pacific Missile Range Facility, Hawaii, involved the rare event of an actual destruction and sinking of a decommissioned or retired Navy ship. In this instance, firing of the SM-6 was designed to analyze new software configurations on the missile, giving it an ability to track and destroy targets on the surface of the water, as opposed to its typical use of hitting or intercepting incoming enemy fire from the air above a ship or near the Earth's atmosphere as a ballistic missile defense weapon. Using the SM-6 as an offensive weapon against surface targets is a new application for the Navy, bringing another kind of surface firepower to the fleet. The SM-6 is larger than the SM-3 interceptor and is designed to destroy closer in-air targets. However, this test launches the ability for the SM-6 to function in an additional capacity as an offensive weapon against a wide range of surface targets. The entire system was tested. It performed exactly as we expected and the result more than met our expectations. We added to the sea-based terminal capability, ballistic missile defense, and anti-air defense, Campisi added. In effect, this will allow the fleet to attack ships with offensive capability and prove out the flip side of area defense, which is distributed lethality. All of its different functions, he explained. The system will identify a target and send a signal to the firing ship. Based on the signal, it chooses the software path and the activities it is going to perform in engaging its mission, Campisi said. The SM-6 weapon has been operational since 2013. The Navy has at least 250 of the missiles in its arsenal. Last year, the Navy awarded Raytheon a $270 million deal for 2016 SM-6 production. SM-6 technology. The USS John Paul Jones, an Arleigh-Burke-class destroyer, fired the SM-6 using onboard fire control technology and Aegis radar systems equipped with the latest fire control technology called Aegis Baseline 9. The missile's final assembly takes place at Raytheon's state-of-the-art SM-6 and SM-3 all-up-round production facility at Redstone Arsenal in Huntsville, Alabama. An emerging Navy technology called Naval Integrated Fire Control, Counter-Air, or NIFCCA, also relies upon the SM-6 to help track and destroy approaching anti-ship cruise missiles from distances beyond the horizon. The NIFCCA system, which was first deployed last year, also relies upon an airborne sensor to relay a signal from an approaching enemy target. The Navy has tested an E-2D Hawkeye surveillance plane and an F-35 as the airborne sensor able to relay targeting information. The SM-6 is configured to fire from Navy cruisers and destroyers out of a vertical launch system too. Although there is not yet a ship deck-mounted launcher for the missile, it appears conceivable that the Navy could explore an option along these lines. This would enable the weapon to fire from a wider range of ships such as the Littoral Combat Ship, frigates, amphibious assault ships or even aircraft carriers. The development of this weapon, along with other missiles and emerging offensive and defensive technologies, is entirely consistent with the Navy's distributed lethality strategy. This ongoing effort aims to better arm ships with next-generation communications technology and cutting-edge, longer-range offensive and defensive weapons. This is informed by a series of key concepts such as a force to better enable surface ships to conduct open or blue water combat against a near-peer adversary, sustain the Navy's global technological edge, hold enemies at risk from farther distances, and allow surface ships to both aggregate and distribute or disperse as needed as a way to reduce the prospect of a successful enemy attack. SM-6 technology. The USS John Paul Jones, an Arleigh-Burke-class destroyer, fired the SM-6 using onboard fire control technology and Aegis radar systems equipped with the latest fire control technology called Aegis Baseline 9. The missile's final assembly takes place at Raytheon's state-of-the-art SM-6 and SM-3 all-up-round production facility at Redstone Arsenal in Huntsville, Alabama. An emerging Navy technology called Naval Integrated Fire Control, Counter-Air, or NIFCCA, also relies upon the SM-6 to help track and destroy approaching anti-ship cruise missiles from distances beyond the horizon. The NIFCCA system, which was first deployed last year, also relies upon an airborne sensor to relay a signal from an approaching enemy target. The Navy has tested an E-2D Hawkeye surveillance plane and an F-35 as the airborne sensor able to relay targeting information. The SM-6 is configured to fire from Navy cruisers and destroyers out of a vertical launch system too. Although there is not yet a ship deck-mounted launcher for the missile, it appears conceivable that the Navy could explore an option along these lines. This would enable the weapon to fire from a wider range of ships such as the little combat ship, frigates, amphibious assault ships or even aircraft carriers. The development of this weapon, along with other missiles and emerging offensive and defensive technologies, is entirely consistent with the Navy's distributed lethality strategy. This ongoing effort aims to better arm ships with next-generation communications technology and cutting-edge, longer-range offensive and defensive weapons. This is informed by a series of key concepts such as a force to better enable surface ships to conduct open or blue water combat against a near-peer adversary, sustain the Navy's global technological edge, hold enemies at risk from farther distances, and allow surface ships to both aggregate and distribute or disperse as needed as a way to reduce the prospect of a successful enemy attack.